If you've worked with data, I'm sure you've come across outliers or those annoying data points that just don't seem to fit with the rest of your data. So what are outliers? Outliers are basically data points that differ significantly from all your other observations, right? So this can lead to, of course, incorrect analysis or inaccurate conclusions. So that's why it's important to handle your outliers, or basically remove them as part of your data cleaning process. So in this video, I'm going to show you how to remove outliers using the IQR method, or the interquartile range method, which I would say is the most commonly used, or kind of the best practice way to remove your outliers from your data. Of course, there's other methods like z-score and a few others out there, but we won't touch on those in this video. In this video, I'm going to show you the IQR method. So let's get started. So the first thing I'm going to do is import my libraries that I'm going to use in this example. So I'm going to import that. Next, I'm going to import the data set that I'll use for this analysis. So in this example, we'll be using one of the built-in data sets in Seaborn. So we'll be using the diamonds data set. So let me just load that. So let us just preview our data here. Cool. So yeah, there seems to be a number of variables about basically diamonds in the data set. I'm not going to use all of them. For this example, let us just choose 3 variables out of all of these. So I will work with carat, I think this one, depth, and price. So let me store that in another data frame called df_clean, where I'm just going to be selecting these 3 columns. And let me hit enter. Cool. Now I'm going to select our columns as well. So since we're going to work with these 3 variables, I'm going to store them. And then what we'll do is to actually try and plot this data, these 3 variables in box plot, so that we can see how they look like. So I'm going to write the code here, which is used to plot them into box plots. If this looks overwhelming, it's really not. What this is doing is basically plotting all the data into box plots from the df data frame for just these columns. And this part is basically telling it to show 3 box plots in one row. So that's 1 by 3. And then this is the overall size of the plot. So let me just hit enter to see how this looks like. Perfect. So we now have the plots of the 3 variables. And as you can see, these box plots show us that there's quite a number of outliers in all 3 variables. So outliers are generally those data points that kind of cross beyond these left hand and right hand whiskers. So if you see a lot of these data points, means your data set has a lot of outliers. So just as I was going through the code, you'll notice my box plots are arranged horizontally. So that is done through this line here, orient equals h. That is just my preference. I think it's more visually easier to see box plots in this format rather than vertical. And this color here basically makes it look teal, as you can see. So next, let's actually start removing these outliers using the IQR method. So before I go into the code, let me just quickly show you how the IQR method works. So basically what the interquartile range, or the IQR, is the difference between your 3rd quartile and your 1st quartile. So your median is your 50th percentile, your 3rd quartile is your 75th percentile, and then your 1st quartile is your 25th percentile. So the difference between the 75th percentile and the 25th percentile will be your IQR, right? So then if you multiply 1.5 to that difference, to that IQR, and you add it both sides, so you add it to your Q3, your 3rd quartile, and then you add it on the other side to Q1 as well, whatever that kind of boundary or extension that generates is your outer bounds. So then any data point that's outside of those left hand and right hand bounds is considered an outlier. So that's basically how IQR works. If you're interested in, like all the math behind how this was derived, feel free to look it up, but I'm not going to go through all of that. So the next step here would basically be to replicate all this math in Python, right? So the first thing I'm going to do is calculate the first quartile and third quartile for each column. So I can do that by doing something like this, where I will calculate the IQR as the difference between the third quartile and the first quartile. Cool. Now that we have our IQR, the next step would be to actually define our outliers based on the IQR. So what I'm going to do is store the logical condition in outliers underscore IQR. So basically I'm saying anything that's less than Q1 minus 1.5 times IQR. So this basically is accounting for this portion here. So anything that's beyond this range, or anything that's beyond the right hand side, right? So with greater than Q3 plus 1.5 times IQR. So this is an OR condition. So if it finds an outlier either on the left side of the box plot or on the right side of the box plot, in either of those cases, if any of those is true because of this OR condition, it's going to consider that as an outlier and store it into this variable, right? So then we'll use this variable to kind of exclude the outliers from our data set. So how you can do this is basically filter the data set by saying df underscore no outliers underscore IQR. So this is just a new data frame where we'll store our clean data, and then you want to exclude basically outliers underscore IQR, which is this, and then we will try to plot this in the box plot just like we did with the original data. So let me run that. Perfect. So as you can see, our data looks much cleaner now. In this first set of box plots, we have quite a number of outliers, and after removing the outliers based on IQR method, the data looks much cleaner, and we seem to have removed quite a significant chunk of outliers here. One thing you can also do is actually compare the before and after box plots side by side. So how you can do this is using something like this, where basically you create a box plot before removal and then after removal, and then kind of loop through all the variables. So I'm going to run this. So there you go. So this plot basically shows me for each variable, for example, depth, how did the box plot look like before outlier removal and how it looks like after outlier removal. So this is, I think, a very handy way to look at data side by side. Next, we'll try to see how many rows of data were actually removed. How you can do this is by basically getting the difference between the rows before and the rows after, and then calculating the percentage. So if I run this piece of code, it basically shows me that it removed 6,049 rows or 6,049 outliers, and that was 11% of the data of all the rows in the original data. So we actually removed a significant chunk of data here. And then you can also kind of see per feature or per variable how many outliers you removed. So you can do this by using a piece of code like this, where if I run this, it's going to show me the number of outliers per feature. So for each variable, we had these number of outliers and the percentage of outliers that were removed for each variable. So I think that's a pretty handy way of kind of making sense of what you actually, how much you actually removed, because sometimes just doing the, IQR method can be a bit confusing, where you lose track of what you're actually doing in the bigger picture sense of things. So in this way, you can easily tell how many percent of outliers you removed. So there you have it. That is how you remove outliers using the IQR method in Python. So I hope you found this video helpful. Don't forget to like and subscribe.